Okay, gang, this is from chapter review 3, page 250. It's graphing logs. Graphing logs, you learned about that in section 3.2. So if you're having trouble with this topic, you can go back to the lecture on 3.2. Okay, so remember, when you're graphing a log, it's going to have a vertical asymptote. It always has a vertical asymptote. The vertical asymptote occurs where the inside of the log is equal to 0. So for instance, what's inside the log this time is x plus 5. So the VA is going to occur when x plus 5 equals 0. Okay, which means that so if I solve this, it's going to occur at -5, right? Because this graph, if you remember, it's always opposite of the inside. So this graph is pushed 5 units to the left, right? It's always opposite of the interior. So you're going to be required to always have the vertical asymptote, you know, on your test, on your final. So make sure you have that. So there's 2 ways to think about it. My brain likes to think that this graph is shifted 5 units to the left, so it's right here. It's basically when you try to do the log of 0, right? So the other way to do it is when you have x plus 5 equals to 0, you get -5 here. All right, so this is pushing the graph 5 units to the left. This negative in front of the log is a reflection over the x-axis, because usually the graph would look like this. It would look like a hook, but it's being flipped over the x-axis. So instead of it kind of going upward, it's actually going to flip. It's going to go downward. It's going to come down this way. It's x going to be like decaying. And this 4 is pushing the graph 4 units up. 4 units up. All right, now I'm going to want you to have the X and Y intercept. So let's do that first. So the the Y intercept is how you always find it. You're just going to let X be 0. Now you're going to need a calculator for that. Because when you let x be 0, you're getting 0 plus 5 here, right? X is 0, you get 0 plus 5. Which just means you're taking the log of 5. You don't need the parentheses because it's just one term. But this is base 10. So you want to find out what the log of 5 is. So you're going to do, hope you can see that. Okay, log, you're going to do log of 5. Get in the habit of closing this. Hit equal, so it's about, let's round it to about 0.7 just to keep the numbers nice. So this is about 0.7. So this is like doing 4 minus 0.7. So we're going to end up with 3.3. Okay, because 4 minus 0.7 is 3.3. So the y-intercept is when it's at 0, 3.3. And we already know the graph's coming down because of this negative here. All right, let's pretend it's somewhere right about there. That's sort of like 0 and 3.3. All right, now let's go ahead and find the x-intercept. Even if on the test or the final it's too large to graph, I still want to see that you found the value, okay? So when you do the x-intercept, like always, we're just going to let y equal to 0. So up here, we're going to let f or y equal to 0. So 0 equals to, I'm just going to rewrite this guy, 4 minus log x plus 5. All right, so you have to remember how to solve a log to do this, right? So to solve a log, you have to isolate the log. So to me, the easiest thing to do is just add the log to the other side. Right, you're going to just move the log over here. And that'll make it positive. If you move the 4 first and made it a -4, just then make sure you divide by the negative. It doesn't matter who you move where, you're going to get the same answer as long as you're doing all your steps correctly. Okay, so I move this over here. So again, we're solving a log. This is base 10. So it's 10, so you can see this number is going to be huge, right? It's 10 to the 4th power, because now I have to rewrite it in exponential notation. 10 to the 4th power equals to x plus 5. Right? 10 to the 4th is 10 times 10 times 10 times 10, right? 10 times 10 times 10, you're going to have 4 zeros there. Right? That's 10,000. Right? We're not going to be graphing that, right? And then you would just have to subtract the 5 from that. Yeah, so we're not going to be graphing that guy. Unless your graph paper is more like a scroll. But I do want you to find it, okay? So let me be clear on that. So that's like way, way out here. All right, so since that's so far out, we have to then find something that we can put on our graph paper. So let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, since it's base 10, if you like logs and you like bases, 10's a really good one to pick, right? And if you're not, oh, I should say 5. Let's do 5. 1, 2, 3, 4, 5. Let's do 5 first. So I'm going to let x be 5. So, and I'm going to solve for y. So y equals to, if you're not on the same page as me, you'll get there. Just give me a moment. I'm very visual, and I know a lot of you are, so you'll see it once I start writing it out. All right, so 5 plus 5 is 10. Right now, you know from your log properties, if these match, these are going to, I don't want to say cancel out, they just sort of become what the exponent is. So this is going to end up being 4 minus 1, right? Because log 10 of 10 is 1. And then this is going to end up being 3. So we know when x is 5, y is 3. So anything base 10 would be a really good one to do. All right, so as you can see, that does almost nothing for us, but it does give us another point. As you can see, the x-intercept is so far out that this is going to stay high. This is going to stay high. So let's go ahead and put in -4, okay? And you can probably figure out where I'm going with that. Let me see if I can squeeze a little spot in here. Let's let x equal to -4. That's a real easy point to do. All right, so if we let x equal -4, we have y equals to, or f, if you want to keep it as f, 4 minus log -4 plus 5. So y is equal to 4 minus log, right? -4 plus 5 is 1. And we know from log properties, log of 1 is always what? Log of 1 is always 0. Doesn't matter what the base is. Doesn't matter what the base is. Log of 1 is 0. So we get 4 minus 0 or just 4. So when we put in -4, we get out 4. All right, so when we put in -4, we get out 4. So this is my point, -4, 4, and over here is my point 5, 3. Oh, I'm already at 9 minutes. Okay. Now again, you have to know what these shapes look like, because if you don't, I get students hand in, like I'll actually have some students will draw a straight line here, which is absolutely wrong. You have to remember that logs look sort of like hooks. So let me just get a different colored pen here, it might help. Logs look like hooks, right? So I need to make this look like a sort of a hook-like shape. And again, I can't fit the X-Intercept, so I'm just gonna, it looks like to be continued sort of graph. All right, and and then that is what the log is going to look like. So I'm looking on the test that you have the intercepts. I'd really like to see 3 points. That would be ideal. Okay, 3 points, any of the intercepts. Okay. All right, gang, that's it on this one. I'll catch you. Bye-bye.